I just handed almost all of you this paper. We're talking about a couple theorems today. The first one is called triangle angle sum theorem. Triangle angle sum theorem. It's a silly name, but it's talking about the sum of the angles in a triangle. And we know the sum of the angles in a triangle is, anybody know? 180. Awesome. We already know that. That's all we're working on today. I'm going to have to fill in some of these diagrams because the numbers didn't copy over, but all we're essentially doing is dealing with that principle today. So this first one's box is, oh God, where's this paper? 38, and this is X, and this is 25. How do you find X? I just made those numbers up. You didn't have those. How do you find X? Anybody? Any idea? Yep, Cooper. Uh-huh. Perfect. So we add up all the angles we have, make it equal to 180. So we're going to set up an equation. You can kind of MacGyver your way through this to do just kind of simple math, but I'd rather you do an equation because you'll see coming up after this, it's going to be helpful to have an equation done. So 38 plus X plus 25, add my angles together, I get 63 plus X equals 180, and then we minus 63, X equals 117. All right, the next one, what our angles should be are 3x minus 1 and 31. There you go, so you can see all of them. What's that one angle I didn't label? What do we call that? 90. It's a right angle right there, so that's 90. Again, we're going to do the same thing. Add them up, set them equal to 180. I'm going to write 90 in there just in case I forgot. And I'm going to do 3x minus 1 plus 90 plus 31 equals 180. Combine my like terms. Negative x, positive 90, positive 31 is 120. 3x plus 120 equals 180. 3x equals minus 120 from both sides, I get 60. X equals 20. We doing okay so far? Next one is very similar, but now we have to draw the picture. And it describes to us what all my sides are going to be. Or excuse me, all my angles. So it says in triangle DEF, measure of angle E is 3 times measure of angle D, and measure of angle F is 9 less than measure of angle E. What's the measure of each angle? I'm going to draw a triangle. It doesn't matter what my triangle looks like. I'm just drawing something so I have a visual. And I'm going to label my angles D and E and F. Anyone know what I should label my angles? If I know X is 3 times D, what should be 3X? E. And then what should angle D be? X, good Colin. And then angle F, it says, is 9 less than measure of angle E. 3x minus 9, awesome, good help on that for me, guys. 3x minus 9, and we're gonna do the same thing we've been doing. Add them up, set it equal to 180. I see some of you furiously writing away because you're hustling through it. Set up my equation, I combine my like terms. I add 9 to both sides, and I divide by 7. Now it doesn't just want X, it wants all of the angles. Say again? Plug it in. It looks like I already have measure of angle D because that one is X. So I already have measure of angle D. E is going to be 3 times 27, which is 81. And then minus 9 is 72. All right, we doing good so far? Any questions? All right. The next part is adding to our idea of triangles. Now it's talking about an exterior angle. What does exterior mean? I heard it. Outside, just outside the triangle. Technically, it's formed by one side of the triangle and the extension of its adjacent side. So if I were to like extend the line out, it forms a linear pair with an angle of the triangle. And linear pairs are what? Supplementary. That should be like, as soon as I say linear pair, you should say in your head supplementary. So if I'm looking at this picture, everything that's inside the triangle are these things. It's all in yellow, 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 yellow. And my exterior angle in this case is angle 4 because it's made with this side of the triangle. And then if I were to extend the bottom of the triangle out, that's how we made angle 4. So I'm going to write angle 4 is an exterior angle. It's a linear pair and then thus supplementary with angle 2. Now there's another vocab word I want to tell you about, which is remote interior angle. Have you heard of a remote destination? Or like a remote island somewhere in the Pacific? Like I think that's a phrase that you hear in books or history or whatever. That's somewhere very far away. So if I'm talking about a remote interior angle, I'm thinking about the angles inside that are the farthest away from my exterior angle. In this case, angle 3 and angle 1 are remote interior angles because they're inside the triangle, but they're the farthest away from angle 4. The interior angles of a triangle that are not adjacent to a given exterior are called the remote interior. So I just read the definition right there, and I just explained why 1 and 3 are remote interior angles to angle 4. Okay. All right. We're going to find measures of angle X and Y in here. So I would have had to give this to you. I'm sorry, I have to like kind of self-draw this on here. That top angle is 115. And then the angle on the right is 35. And then the other interior angle is X and the exterior angle is Y. I want to find Y, but first we need to find X. How do we find X? Add a map set equal to 180. Which is 150 plus X equals 180. And that makes X equal 30. Mm-hmm.
Well, if we do homework on this, we have to write out that whole X process. Select that,
you can just, on this one, since you didn't need necessarily an equation to solve, you can just tell me X is equal to 30. When we had other ones like up here with the expressions, I do want an equation. All right, now let's find Y. What's the relationship between X and Y again? Linear pair and linear pairs are? Supplementary. Good, more of us said that. I love it. So we're going to do X plus Y equals 180, or you can minus 30 from 180, whatever makes you happy in your head. I do know that X is equal to 30, so I have 30 plus Y equals 180. And then we minus 30, or Y equals 150. All right, pretty cool, right? All right, I just gave you made you do a long version that's something I'm about to give you a shortcut for. So flip your paper over, we're gonna do a shortcut now. It's a new theorem. This theorem is called triangle exterior angle theorem. So this is called the triangle exterior angle theorem. Again, we're not super creative with names. It's triangles, it's exterior angles, it's a theorem. Bless you. It says the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So if we just kind of reflect back on the problem we just did, I made you find the other interior angle, and then we found the exterior angle because we knew that they were supplementary. This new theorem that I just now told you means that we didn't have to do all that work. We could have simply added up 115 and 35, and that's what y would have equaled. And that's what we got over here. When I did 115 plus 35, I got 150. And then when I found y the normal way, I also got 150. That proves that I could have just added those two angles and I would have gotten my answer. Cool? We're going to use that for the next two problems. So it says find the value of x. So let me give you some things in here. I'm going to tell you that x is this top angle right here. And then 112 is my exterior angle. What I just taught you, that theorem, states that if I do x plus 90, that will equal 112. My two remote interior angles sum to equal the exterior angle. So I'm going to write x plus 90 equals 112, and then I can solve. Minus 90, x equals 22. We okay with that? All right, let's do another one, very similar. In this one, this angle right here is going to be called 6x minus 7. The point is going to be 2x. And then the other inside is going to be 103 minus x. Again, I've got an exterior and I have two remote interiors. Can someone write my equation for me? Which two add to be the third one? We got 1, 2 people now, 3, 4, 5. Cooper, can you help me? Uh-huh. Good, so 2x plus what? Good. Equals what? Perfect. Awesome, now get your mask over your face. That's all right. Any questions on that? So as Cooper said, he said the two inside add to be the outside. So we add the two inside and equals the outside, and now we just combine like terms. I have x plus 103 on the left equals 6x minus 7, and then I got to get my like pieces together, minus x from both sides, add 7 to both sides. I get 110 equals 5x, and then divide 110 by 5, and I get 22. Oh, nice, the same answer. Any questions so far? Everybody with me? All right, we got one little piece left. 5 more minutes, 4 more minutes, perfect timing. Okay, yes. Realize that there's a lot of sections on the quiz, so I can't really ask like 50,000 questions of this. There'll probably be like maybe one of the like exterior ones, and then like maybe a normal like one like number 3. I will give you a review tomorrow, and that will be a better idea of kind of what could be on it. Okay, last thing is corollaries. Corollaries are basically mini theorems. Mini theorems. So we know theorems are like those big statements that we assume are true. Basically, a corollary is like can be easily proven from another theorem. I think there's like some kind of hierarchy with these theorems and corollaries and postulates. At the end of the day, we're going to trust all of them as truth and fact. But if I use the word corollary, it's just a statement that can easily be proven from another theorem. It's a mini theorem. So we're going to talk about a couple right in here. The first one says an acute angle, or the acute angles of a right triangle are, in this case, they are complementary. What does complementary mean again? 90, good. They adds to 90, sums to 90. Awesome. So if it's a right triangle, one of the angles is already 90, which means that the other two together make 90. So that means that they're complementary. If I were to write a math statement, I'd say measure of angle A plus measure of angle B equals 180. All right. And then the other corollary is kind of an oh duh thing. There can be at most, so no more than one, right angle or obtuse angle. No more than one. Which makes sense, because if they add up to 180 and you have two right angles, you don't have enough angles for another piece. Like you're just done. All right. Last it says the measure of one acute angle of a right triangle is 5 times the measure of the other acute angle. Find the measure of each. All right, I'm going to draw a triangle. What kind of triangle am I going to draw? A right. Very good. Read the problem. It says right. Which means that I have to label one of my sides. It's not all what I wanted to do. I have to label one of my sides as 90. My other angles, it says the measure of one is 5 times the measure of the other. What should I label these angles? Jane? X and 5x, very good. One of them has to be just x, and the other one is 5 times that, so x and 5x. How would I go about solving this? How would I find x? Cooper? It depends on what you want. What are you setting them equal to? So it's one of two things. If I was just going to do these two angles, they're just equal to 90 because the other angle is 90, which means these two are complementary. So I could do x plus 5x equals 90. However, if you're afraid of like messing something up and you're like, no, I always want to add to 180, that's fine, but you have to include the 90. What some people want to do is they want to say x plus 5x equals 180, and that's not right. So we're going to add the 90 in. So we could do x plus 5x plus 90 equals 180. Personally, I would do this one to solve. The other one is also fine. Because there's less room for error. All right, I'm going to pass out homework and I'm going to spray the desks. If you want a piece of paper for homework that is due tomorrow, make sure you get one from me. If you want to do it on Schoology, I just put it up. I had to change the assignment, so if you got a head start on it, it's not the right one, so you might have to redo it. All right. Here comes homework. Eli, will you want a paper?
Yes.
Here I come. It's like only 2 kids in my other class that did it. All right, clear your desk off so I can come spray you.
I've been recording this whole time.